Most AI systems today generate answers. Idea builds a semantic operating system underneath AI, making knowledge visible. Instead of treating knowledge like disconnected documents and prompts, we organize meaning itself across language, concepts, decisions, workflows, and downstream effects. What you're about to see is how enterprises move from isolated AI chats to traceable, governable, organization-wide intelligence. This is the semantic foundation of the platform. We combine formal ontologies like BFO, CCO, RO, and IAO with Framebase and WordNet to create a unified knowledge layer. Why does that matter? Because enterprises don't just need AI to generate language. They need AI to understand actions, intent, responsibility, and of course, consequences. Frame semantics let us model not only what was said, but what decision was made, who acted, what systems were affected, and what downstream impact could occur. That creates what we call a decision blast radius. When an AI agent makes a recommendation or when a human makes a policy change, we can trace semantic impact across connected systems, workflows, and knowledge domains. This becomes critical for governance, compliance, operational risk, and explainable AI. This is the meaning field. Every point represents a semantic neighborhood of knowledge inside the organization. Instead of storing information as isolated files or vector blobs, we organize meaning spatially. This allows AI systems to navigate knowledge more like humans navigate conceptual space. Nearby regions share semantic affinity. Distant regions represent conceptual divergence. This gives us semantic routing, locality-aware retrieval, and explainable traversal through organizational knowledge. Now we drill down into a single semantic region, a voxel. Inside this area, we can see sentences, extracted objects, semantic frames, references, and role relationships. This is where the richness of the graph becomes powerful. We're not just retrieving text, we are building idea inventories. The platform understands concepts, actors, actions, dependencies, semantic roles, and contextual relationships. This enables explainable AI responses, semantic auditing, knowledge reuse, agent coordination, and advanced enterprise search. The graph becomes an operational memory layer for AI systems. Frames allow us to understand how ideas interact operationally, not just linguistically. IDEA is model flexible. Organizations can connect frontier models, open source reasoning models, domain-specific models, Hugging Face ecosystems, or internal models. The graph becomes the stable semantic layer above the models. That means organizations are not locked into a single AI vendor or model lifecycle. The knowledge architecture persists even as the models evolve. This is selective AI. Instead of unconstrained generation, the system assembles responses from semantically governed knowledge structures. Notice the confidence score in the citation structure. Now we move from retrieval into orchestration. Using ontology-defined tools and semantic structures, the system can coordinate reasoning workflows through our internal model, in this case, Quinn. Here, the platform generates an AI readiness SWOT analysis. The key difference is that the reasoning is grounded in structured semantic context from the graph. We call it a subgraph. This creates high-quality strategic outputs while maintaining explainability and organizational alignment. The ontology defines the operational vocabulary for AI execution. Here, the system surfaces an AI readiness framework with lower confidence, and that's crucially important. Traditional AI systems tend to overstate certainty. IDEA exposes semantic confidence directly. This allows organizations to identify gaps in organizational knowledge, incomplete semantic coverage, and areas requiring human review. The platform is designed to augment human judgment, not hide uncertainty. Now we let Quinn expand the answer. But instead of starting from an empty prompt, the model begins with a semantically constrained subgraph. The graph provides the conceptual seed of definitions, relationships, frames, objects, and contextual grounding. This dramatically improves consistency, traceability, and alignment with enterprise knowledge. The model generates language. The graph governs meaning. And this is where it all comes together. The ontology structures meaning. The semantic field organizes knowledge. The graph preserves the relationships. Selective AI governs retrieval and composition, and frontier models provide advanced reasoning on top of it all. The result is an enterprise semantic operating system capable of explainable AI, agent orchestration, semantic governance, organizational memory, and traceable decision intelligence. We believe the future of enterprise AI is not just bigger models, it's structured meaning.